Optimization is a huge branch of mathematics because generally in real life, we want to find out the best that we can do. So basically, if we're talking about business, maybe we may be looking for the maximum amount of profit. If we're talking about construction, we may want to use the minimum amount of material to get the job done. So anytime we're looking to maximize or minimize something, this is called optimization, and there's an entire branch of mathematics based on that. So we're going to take a look at just a few very simple, not necessarily easy, simple examples of how to do this. Let's take a look at an example like this. Let's say that we're making something. Let's say we're making bikes. And the price of the bike is given by the function little p of x is 1,000 minus x. So you set up this company and you did some studies and you found that the best way to determine the prices is where x is the number of bikes that you're going to sell. So the price should be 1,000 minus that, where x is the number of bikes. So now, does this kind of idea make sense? Well, it should if you think of it from a business point of view. If you're going to make a profit and you know you're only going to sell one bike, 1,000 minus 1, you're going to have to sell that bike for a lot of money, right? Because you only have one of them. However, the more bikes you sell, the less you actually have to charge for those bikes to still make a profit, because you're making a little bit of profit off each bike. So let's say that we decided this was it, and we know just from running our business, the cost of running our business, excuse me, let's say is $3,000 a month. Let's say it's overhead, electricity, building, all that, plus $20 per every bike that we make. Now the idea for a cost function like this, generally you have a set cost which is called your overhead, like I said, electricity, rent, those kind of things. Plus you have a cost for everything that you make, right? So apparently each bike that we make costs us $20 to make. All right, so let's go through and answer a series of questions that would be pretty important in here for these things. Let's put them down here. What is your revenue? 2. What is your profit? That's both good questions, right? Now, of course, these are going to be functions, our revenue function, because it changes, of course, with the number of bikes that we sell. How many bikes do we need to sell to maximize the profit, right? That's always the number one question in business. How do we maximize our profit? So we're selling bikes. How many bikes do we need to sell to maximize our profits? And yes, anytime you're manufacturing something, it actually has a point to where it tips over and you start making less money per unit. Because let's say you got a crew that works 40 hours a week and they can make 100 bikes. Well, if you want them to make more bikes, you're probably going to have to pay them overtime, which is more cost. Your cost function goes up, which means your profit function goes down. So there's a little balance there. So if we want to know how many bikes that we need to maximize the profit, a good thing is what is the max profit? So how much money could we possibly make underneath this setup? And 5, once we decide that, that'll tell us how many bikes we need to sell. That'll tell us at what price we need to set the bikes. So what is the price for the bikes to maximize the profit, of course. All right, so what do I got? 5 questions there. So let's see if we can go through and answer them slowly. So first off, revenue. Now our revenue function's not given here, but we are given a price function. Now remember, revenue is the amount of money you bring into your business. So revenue, how much money are we going to bring in? Well, it's going to be how much each bike cost times the number of bikes that we sold. So our revenue is going to be x times little p of x which is x times 1,000 minus x, or 1,000x minus x squared. Okay, there's our revenue function. What's our profit function? Well, our profit function is very simple. It's how much money we take in minus how much money we gave out. So our profit function, now that's big P, be careful, the little p is the price, big P is profit, is going to be your revenue minus your cost, like always. So our revenue function is this, minus x squared, minus our cost function, where's that at? 3,000 plus 20x. So if we simplify that, let's see, I'm going to have a negative x squared. 1,000x minus 20x is 980x minus 3,000. Okay, so there's our profit. Okay, so far we haven't really done any calculus yet. We haven't talked about optimization. The next couple of questions are talking about optimization. Anytime you're talking about finding the minimum or maximum of something, you're trying to optimize it. So our next question says, how many bikes do we need to sell to maximize the profit? Now the profit here is what we're maximizing. That's generally called our primary function. We'll see that in the next problem a little bit more in detail, but that's what we're maximizing. So anytime you're trying to find a minimum or maximum, you know you're looking for the derivative. So to do that, by the way, that's a plus right there. We're looking forward to max profit stuff. That's really what we're looking for here. I'm looking for P prime of x. Well, the derivative of this statement here is negative 2x plus 980. Like always, we want to know where that's equal to 0 and undefined. That never changes. So when it's negative x squared, I'm sorry, negative 2x, look right here. Negative 2x plus 980 equal to 0. Negative 2x is negative 980. So when x is, what's half of that? 480? Is that right? 490. I can't divide. 490. Okay, so what does this value stand for? Well, x is the number of bikes sold. So if we want to maximize our profits, we need to sell 490 bikes. So that's this question. How many bikes do we need to maximize our profit? We need to sell 490. Now you could do this if you just want to be safe. You could put this on a number line like we always do. 490. Pick values on each side and check it. Most of the time, as long as you did your math right, it should be either minimized or maximized. All right, so there's our value. So there's how many bikes that we need to sell for our profit. So I'm going to go ahead and just squeeze that answer in here. So we need to sell 490 bikes. Okay, the next question, what is the maximum profit? Well, that's easy enough. To find the maximum profit, we know our profit function is negative x squared plus 980x minus 3,000. And I want to know what that profit is if I sell, what did I say, 490? Yeah, 490 bikes. So we would plug that in here. So that's negative 490 squared, 980 times 490 minus 3,000. Okay, so grab yourself a calculator. I cheated, by the way. You can't see it, but I actually wrote the answer over there because I knew I wouldn't be able to do that in my head. $237,100. So if we sell 490 bikes, that's how much money we're going to make. So that's our answer here. What's our maximum profit? So what did I say? $237,100. Now the question is, to make this amount of money, in selling 490 bikes, what does the cost of each bike have to be? Well, for the cost, or the price of the bike, and remember this is little p of x, we know is 1,000 minus x. We know we need to sell 490 bikes. So if we sell 490 bikes, we need to price them at 490, which would be $510 per per bike. All right, now there's good news and bad news here. This is a pretty simplistic model. There are other things that we're going to take a look at, like market value and demand a little bit later on. Maybe this isn't the bike worth $500. Maybe it's a cheap Walmart bike that's worth $80. So you'll never get that value out of it. So you're gonna have to find a market that it actually can be sold in. All right, so there we go. Notice that in this particular thing, we had a few business questions to answer at the beginning, how to find revenue and profit. But the rest were more the calculus ideas of what we needed. Anytime we're looking for minimum or maximums, you find what function or what you're looking to minimize or maximize, find a derivative, find out where it's equal to 0 or undefined like we always have. That'll tell you where it's either a minimum or a maximum at, and then you plug it back into the original function to find out what that maximum value is. Let's take a look at another example, maybe one that's more physical example. This is a pretty common example. You'll probably see this in a lot of textbooks. Let's say, let's get this out of here real quick. Let's say that you want to put up a fence. You want to build a rectangular fenced-in yard. You have, let's just say for fun, 200 feet of fence. What should the dimensions be to maximize the area? All right, now this is a pretty basic question that you're going to run into optimization problems. So here's the idea. We want to build a rectangular fence around our yard. We know we have 200 feet of fence because that's what we bought. And we want to know what should we make the length and the width of this thing to be to get the most area on the inside, because we want our dog to have the most room to run around. So pictures a lot of times are helpful here, not necessary in a lot of cases. So here we have a length and a width. Now, anytime you read these questions, a lot of times there's a couple of things that you're going to have to work with. So, first thing you want to look for is what are you trying to minimize or maximize? Well, the question generally is going to throw that at you. We want to maximize the area. So that's the function we're going to be taking the derivative of. Well, can we come up with a formula for the area? Well, we know the area of a rectangle is length times width. Now, we could start taking the derivative now, but the problem is this has too many letters in it. We only know how to take the derivative of stuff that only has one letter in it. So that's what we want to take the derivative of. This is what we want to minimize or maximize. This is called our primary equation. Now, in our last example, our primary equation was our profit, because that's what we wanted to take the derivative of, or minimize or maximize. Now, in our last example, that only had one letter in it, so we could just go ahead and do that. Now, that's our primary equation, but it has too many letters in it, so we're going to have to figure out how to get that down to down to just one letter. Well, we do have a constraint in this problem, and in most real-life problems, you do have a constraint, something that you have to live by. Now, this thing says, what's the maximum area? Well, if I had an infinite amount of fence, I can make this as big as I wanted to. I can make it infinitely big. But I don't have that much fence. I only have 200 feet of fence. So that's a constraint. So what does this 200 feet represent in this problem? Well, that's the distance around the outside, or the perimeter of this rectangle. So we know the perimeter of our rectangle is twice the length plus twice the width. And since our perimeter has to be 200, this is called our secondary equation, or sometimes called the constraint equation. Now, this equation is actually going to be really, really helpful for us, because this is the one that's going to help us get our original equation, our primary equation, down to one letter. So take your secondary equation and solve for one of the letters in there. Notice our constraint equation and our area equation have the same letters in them, right? So take this and solve for either length or width. I'm going to solve for length. So if I take this, I'm gonna bring it down here so that 2L plus 2W. I said I'm solving for width. So let's get the length to the other side, minus 2L. So I get 200 minus 2L equals 2W. And then if I divide everything by 2, I get 100 minus L is equal to W. Now that I have an expression for W, I can plug that into this equation up here. So use this in the primary equation. So if I take that, my area will now be length times 100 minus length. Or another way to write that is my area will be 100 times length minus length squared. All right, now notice our area equation now only has one letter in it. So now we can take the derivative. Now you can use the prime notation here if you want to. You could write that as A prime. But it's really helpful to kind of see this in terms of the differential notation or the Leibniz notation. So this is, we're going to look for the derivative of A with respect to L. So the derivative of this with respect to L is 100 minus 2L. So we want to know where that derivative is equal to 0 or where that derivative is undefined, like always. Well, 100 minus 2L is equal to 0. We should be able to solve this, and we can see here again, like it happens a lot. This is never undefined. So solving for L real quick, we get minus 2L is negative 100, divided by negative 2. So to maximize our area, we're going to need the length to be 50. Okay, so there's part of our answer. But we also need to know what the width is. How can we figure out what the width is? Well, we know from, I'm going to bring this over here. We know the length is equal to 50, and we know the width is 100 minus the length. So the width would be also 50. Okay, so now we found the dimensions that we actually want our rectangle to be, which technically is still a rectangle, but would actually be a square, right? Because the length and the width are the same. Now notice this does have a perimeter of 200, right? That's how far around it's supposed to be. 50 and 50 is 100, 150, 200. So it is 200 all the way around. Now if I were to ask one more question, what is the area of this? Well, we know area is length times width. 5 times 5 is 25 with 2 zeros. So this would be 2,500 square feet. Okay, so that is the maximum size you would be able to build or maximum area that you'd be able to build with 200 feet of fence. So if you have too many letters in an equation, generally you're going to have to find a primary equation. That's the one you want to take the derivative of. A secondary equation is something that you have to live by, right? We only had 200 feet of fence. I don't have any more, so I got to live by that. Generally, we use our secondary equation to get our primary equation down to one letter. That's what we did here. Take the derivative, set it equal to 0, find out where it's undefined like always. That will find the minimum or maximum value for what you're looking for. All right, optimization is, like I said, a huge field of math. It's always going to be important, especially in business when you're trying to minimize your cost or maximize your profits. So make sure you take a look at this section.